In this lesson, you will learn how to graph quadratic functions and determine their range accurately. Mastering the relationship between a function's domain and its range is essential for scoring highly in the Cambridge IGCSE Additional Mathematics exam, as these concepts form the backbone of the functions and calculus chapters. By the end of this session, you will be able to confidently identify the maximum and minimum values of various functions to state their range in the correct mathematical format. Today, we will look at determining the range of functions, starting with quadratic functions. For a standard quadratic function in the form f of x equals ax squared plus bx plus c, the range is entirely determined by the y-coordinate of its vertex. The value of the coefficient a tells us the direction of the parabola. If a is positive, the parabola opens upwards, like a cup, meaning the vertex is the lowest point, or the minimum value of the function. If a is negative, the parabola opens downwards like a frown, so the vertex represents the highest point, or the maximum value. In both cases, once you find that turning point, you know the boundary of your range. Find the range of f of x equals 2x squared minus 8x plus 5, for x is an element of the real numbers. To find the range of this quadratic with an infinite domain, our first step is to locate the vertex. We can use the formula x equals negative b over 2a. X equals negative 8 over 2 times 2. This simplifies to 8 over 4, which equals 2. Plugging x equals 2 back into our original function gives us the y-coordinate. F of 2 equals 8 minus 16 plus 5, which is negative 3. Now, look at the coefficient of x squared. Since a equals 2, which is positive, the parabola opens upwards. This means negative 3 is our minimum value. Therefore, the function can take any value from negative 3 upwards. We write the range as f of x is greater than or equal to negative 3. Today, we are looking at determining the range for a restricted domain. When the domain is restricted, for example, x is between a and b, we cannot simply look at the vertex. The range is found by comparing the function values at the boundaries and at any stationary points that fall within that interval. Why do we do this? On a restricted graph, the highest or lowest points might occur at the ends of the segment, or at a peak or valley in the middle. If a stationary point, the vertex lies outside our restricted domain, we ignore it and only focus on the endpoints. Visualizing the curve is the safest way to ensure you do not miss the true maximum or minimum. In this example, we find the range of a quadratic function with a restricted domain. Let's solve this step by step. First, we find the stationary point by differentiating the function. Setting the derivative to 0 gives us x equals 2. Now, we must check if x equals 2 is within our domain of 0 to 5. Since it is, we calculate the function value there. F of 2 equals negative 2 squared plus 4 times 2 plus 1, which equals 5. This is a maximum because the coefficient of x squared is negative. Next, we evaluate the endpoints of the domain. X equals 0 and x equals 5. F of 0 is 1, and f of 5 is negative 25 plus 20 plus 1, which is negative 4. Let's visualize this on a graph. We plot the parabola between our boundaries. We mark the stationary point at 2, 5, and the boundary points at 0, 1, and 5, negative 4. By comparing our values, 5, 1, and negative 4, we see the highest value is 5 and the lowest is negative 4. So the range is written as f of x is between negative 4 and 5 inclusive. Let's apply our steps to this Cambridge-style question. We have a quadratic function and a restricted domain. First, we find the stationary point. We differentiate f of x to get 6x minus 12, setting this to 0. 6x minus 12 equals 0, which means 6x equals 12, giving us x equals 2. Is x equals 2 inside our domain of 1 to 4? Yes, it is. So we must calculate the value of the function at this point. F of 2 equals 12 minus 24 plus 7, which is negative 5. Now, we check the boundaries of our domain. X equals 1 and x equals 4. f of 1 equals 3 times 1 squared minus 12 times 1 plus 7, which equals negative 2. And f of 4 equals 3 times 4 squared minus 12 times 4 plus 7. That's 48 minus 48 plus 7, which equals 7. Let's look at the graph. We have our vertex at 2, negative 5, and our endpoints at 1, negative 2, and 4, 7. Comparing the values, the lowest value achieved is negative 5, and the highest is 7. Thus, the range is f of x is greater than or equal to negative 5 and less than or equal to 7. Let's look at 3 frequent errors that can cost you marks in the exam. The first mistake is only calculating the y values for the start and end of the domain. Students often think the range is simply the values between f of a and f of b. However, if the vertex lies within the interval, it will be the true maximum or minimum. Always find the stationary point first. The second mistake is using the x value of the vertex in the range statement. Remember, the domain refers to x values, but the range refers to the output, f of x or y. Your range answer must always use the y coordinates. Finally, students sometimes use greater than when they should use greater than or equal to. In IGCSE Additional Maths, if the domain includes the boundaries with equal to signs, your range will almost always include them as well. Always double-check your signs against the nature of the turning point. When tackling range questions in your additional mathematics exam, keep these 3 professional tips in mind. First, even if the question doesn't ask for a graph, draw a quick sketch. It only takes a few seconds and prevents you from making silly mistakes, especially with restricted domains. It helps you see clearly which point is the highest and which is the lowest. Second, be precise with your notation. If the question uses f of x, your range should be written as f of x is greater than or equal to a value. If you use y, you might lose a communication mark. Always match the notation used in the question. Third, while completing the square is a valid method to find the vertex, using calculus, finding the derivative and setting it to 0 is often faster and less prone to algebraic errors in the heat of the exam. It is a powerful tool, so use it to your advantage. It is time to test your understanding. Please pause the video and try to solve these 3 questions. Once you have finished, press play to check your solutions. For the easy question, we have f of x equals x squared plus 6 times plus 10. First, we find the vertex by setting the derivative to 0. 2 times plus 6 equals 0 gives us x equals negative 3. The y-coordinate is 1. Since the coefficient of x squared is positive 1, the parabola opens upwards. Therefore, the range is f of x is greater than or equal to 1. Next, for f of x equals 5 minus 4 times minus x squared. Setting negative 4 minus 2 times to 0 gives x equals negative 2. The y-coordinate is 9. Because the x squared term is negative, this is a maximum point. So, the range is f of x is less than or equal to 9. Finally, for the hard question, g of x equals 2 times squared minus 4 times plus 1 on the domain 0 to 3. The stationary point is at x equals 1, which is within our domain. We calculate the function value at the vertex. Now we check the endpoints. G of 0 equals 1, and g of 3 equals 18 minus 12 plus 1, which is 7. The lowest value is negative 1, and the highest is 7. The range is negative 1 is less than or equal to g of x, which is less than or equal to 7. Here are the key takeaways from today's lesson. First, always identify the shape of the function. Use the vertex for infinite domains. Check endpoints for restricted domains. And remember, range is the set of all possible y values. To recap today's lesson, first, for a standard quadratic with an infinite domain, the y-coordinate of the vertex defines the boundary of the range. Use the coefficient of x squared to determine if this is a minimum or maximum. Second, when the domain is restricted, you must compare the function values at the boundaries and any turning points within that interval. Never assume the endpoints are the only values that matter. Third, Sketching the curve is the most effective way to avoid errors. Always state your final range using the correct function notation and inequality symbols to secure full marks in your exam.